Good afternoon, everyone. Today we're going to graph a rational function where we have a numerator having a polynomial of higher degree than our denominator, right? So if we think of a horizontal asymptote for this one, a horizontal asymptote tends to be the behavior of our function as the x goes to negative infinity, positive infinity, really, really big values, right? And so if we apply that logic to this function, since our degree is higher in the numerator than in the denominator, the behavior as the x's go to positive and negative infinity, so as x goes towards positive or negative infinity, y is also going to do the same, right? Because infinity squared over infinity will be positive infinity, and negative infinity squared, that'll be a positive value because it's a square, but it'll be over negative infinity, and so positive over negative would send the y similarly to positive infinity and negative infinity. And so we can't really get a horizontal asymptote to come out of that, right? So whenever we have the degree of our numerator being greater than the degree of our denominator, we get an oblique asymptote, okay? An oblique asymptote is a line that is diagonal, not horizontal nor vertical, but diagonal, and it's gonna have an equation of the form y is equal to mx plus b, right? Classic line in slope-intercept form like you learned presumably years ago. So to get that line to pop out, all we're gonna do is we're actually gonna divide our numerator by our denominator. Because remember, a fraction is simply a division, right? And so we can use line division or synthetic division, whichever one you rather, and we're actually gonna divide through this quadratic by this linear factor. So let's go ahead and do that. Now our rather linear factor is x plus 4. You think of that as a factor that produces a root at -4, and I'm gonna use synthetic division. So when x is -4, write the root of our factor in the denominator, then we plug in -4 in our synthetic division. The coefficients of our numerator are 1, 3, and 2 respectively. And now we go through this process, so the 1 drops down, -4 times 1 is -4, and we add 3 plus -4 is -1. -4 times -1 is 4, and we add, we don't really care about that term. So this means y is equal to 1x minus 1, and this is exactly the equation of our oblique asymptote, okay? Next we have a horizontal asymptote. We do get, we don't get a horizontal asymptote, we do get a vertical asymptote, right? Our vertical asymptotes, those are for, let's say, unavailable values of x, right, all the way through. And so those come from our denominator being equal to 0. So that means from x plus 4 being equal to 0, or rather when x is -4. And this is the equation of a line, rather a vertical line. And so x is equal to -4 serves as a vertical asymptote. So now we can start to kind of sketch our rational function, because we know we have a vertical asymptote at -4, something like that. We have an oblique asymptote along the line y is equal to x minus 1, right? That's a line with a slope of 1, over 1, up 1, over 1, up 1, and so on, and a y-intercept at -1. So maybe something like this, right? Or rather, I should probably dot that to make it look like an asymptote, right? There we are. I'll make a line. Oblique asymptote and our vertical asymptote. And now, the rest of our graph, it can be a bit tricky to kind of visualize. Both of these factors have positive leading coefficients, and so I can tell you it's going to be a curve in both of these corners, almost like 1 over x, kind of. We can start by getting our intercepts. Those are typically helpful in giving some structure to our graph and are not too difficult to get. So first off, our x-intercepts, our roots, those come from our numerator being 0, right? Because if we get a 0 in the numerator, 0 divided by anything, unless it's 0, 0 over any non-zero value is 0, right? So 0 in the numerator means a 0 altogether. So that means setting x squared plus 3x plus 2 equal to 0, right? Now we can factor this quadratic nicely as x plus 2 and x plus 1. And so that means the zeros are at x is equal to negative 2, x is equal to negative 1, and so our x-intercepts are at negative 2, 0, and at negative 1, 0, right? So that's somewhere around here and here, okay? And then we can get our y-intercept pretty quickly. The y-intercept is when x is equal to 0, and if x is equal to 0, plugging that into our original function means that every term that has an x goes to 0, right? Because 0 times anything, of course, is 0. So all we have left is the 2 over the 4, which is 0.5. And so that's our y-coordinate for the y-intercept, which is somewhere around here. And now we can start piecing together a sketch, at least, of this rational function. So over here, we're going to go right down the vertical asymptote. And it's going to almost look like a negative check mark, and then follow right along the oblique asymptote. Sx goes to positive infinity, and we're going to get something like a somewhat of a mirror image down here. We're going to follow the oblique asymptote curve and then go down with the vertical asymptote. Always kind of gliding along the asymptotes in both directions, okay? And that's about as good as it gets. So we get our y-intercept, x-intercepts, vertical asymptotes, oblique asymptotes. Sometimes we have horizontal asymptotes. If we have our denominator not being of higher degree than the denominator, or if our numerator is not of higher degree than our denominator. But those are all different cases we can kind of reason our way through. So I hope this helps, and thanks for watching.